Okay, so continuing on with the second problem, we've already graphed y equals radical x plus 4. That's the square root function, moved 4 steps to the left. When x is equal to 0, by the way, you would see that y would equal 2, the square root of 4, that is. We've got that curve. We've got y equals 0, which is the x-axis. X equals 0, which is actually the y-axis. That definitely is going to enclose this region right here. And of course what we can do then is revolve that region, of course, around the x-axis. Now, if we would have seen this days ago, we would have said, well, of course, we are just going to use the disk method. And you may use the disk method for sure. But I do want to make this statement that you can also use shells. Shells, remember, will have rectangles that are parallel to the axis. This is so important that you draw at least one rectangle parallel to the axis. I'll tell you why. Right now you can see that your rectangles would be stacked vertically, up and down. And that tells you so much. It tells you, in essence, that you're integrating with respect to y. And that's so very, very important. As we look at the boundaries for that, of course, we can say we're going to integrate from 0 up to 2. Now, as I've said, really every rectangle is going to be drawn in here from y equals 0 to y equals 2. There would be, in theory, a rectangle drawn in when y is equal to 0.7 or 1.4. And I'm just drawing an arbitrary rectangle right now. Now, what you can do is envision that there was a rectangle drawn in at 1.4, just to give you an arbitrary number here. But you could say, how far is that rectangle then from your axis of revolution? Well, you'd say, well, you're 1.4 steps above the x-axis. What you have, though, for the arbitrary rectangle with a value of y here is you will see that it's y minus 0, top minus bottom. To find your height, we have to be very careful. We're going to be integrating with respect to y. And that means that as I'm finding this height, I'm going to do right minus left, but I don't want to have x's inside my integrand. So I'd like to solve for x, actually. I'm going to square both sides here to get y squared equals x plus 4, and then I'd get x is equal to y squared minus 4. That's what this square root function could be thought of as we have x equals a quantity. So suffice it to say, as I go right minus left, we'll be at x equals 0 for that right boundary, so there's 0, minus, and then we're going to have our y squared minus 4. And you should always get a positive value when you work these volumes out. If you didn't, rest assured you made a mistake in terms of the order. You didn't do a right minus left or a top minus bottom. I'll leave it to you to finish this problem. Suffice it to say you should get a volume of 8 pi. And it's very important for you to know, too, that the disk method would get you the exact same answer. To do our last problem, let's say we have a parabola, y equals x squared plus 1, and we have x equals 0, which is going to be the y-axis. X equals 2 is a vertical line over here. Y equals 0 is actually the x-axis. And without too much work, we can see very quickly that we have this green enclosed region. And it doesn't take too much work to see where we're headed here. We're going to revolve about the line x equals 3, a vertical line. And I'd like to encourage you to use shells. As we use shells, we're going to have to draw a rectangle parallel to our axis of revolution. And this rectangle could be drawn in for some arbitrary x value. I hope you can see that we'd be stacking rectangles left to right, meaning, of course, we're going to be integrating with respect to x. So as we finish this up, we're going to say, well, my rectangles will span from x equals 0 to x equals 2. And we can talk about the distance one of these rectangles would be from the axis of revolution. Remember, you could have an x value drawn in for every value between 0 and 2. There will be an x value at 1.4. You will build a rectangle there with a super tiny base. And you could then say, well, how far is this value of 1.4 from 3? Well, again, you could do right minus left. Here you'd do 3 minus 1.4, but really we'd like to write 3 minus x. Then we'd like to find the height of this rectangle. Top minus bottom. You can see that the very top would be x squared plus 1. The bottom would be the x-axis itself, which would be y equals 0. Again, working this out, I'll leave it to you to finish it up using the calculator, but you would get 16 pi. Hope this is going well. We'll continue having another review day tomorrow.